Welcome to this session on gravitational force and field. What we see before us is a diagram which helps us appreciate what a gravitational field is. It's an unseen thing which we use as a model to help us appreciate the area which a gravitational attraction between two objects can take place. Okay. So it's basically the zone of influence of gravitational attraction. And that is what we're going to be looking at. So to start off, a gravitational field is just the area in which there is a gravitational attraction. Let's go into a little bit more detail here. Imagine I have Catwoman. Okay, Catwoman has a mass. Now that mass means that there is automatically an attraction of any other mass to the mass of Catwoman. All other masses are attracted to Catwoman due to Newton's calculations of gravitational force. However, we've also got to recognize that at the same time there is an equal attraction between Catwoman and that of Batman, because Batman has a mass, and therefore there will be a gravitational force attracting Catwoman to Batman as well. This all stems from Newton's law of universal gravitation. Every particle of matter in the universe attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. This is what he came up with when the apple supposedly dropped onto his head. Now we always think about this as a formula, and the formula is F, which is the force of gravitational attraction, equals what's known as G, which is Newton's constant of universal gravitation, which has a value of 6.67 times 10 to the minus 11 Newton meters squared kilograms inverse squared. Okay, the mass of the first object, the mass of the second object, divided by R, which is the distance between the center of masses of both objects. So just to make that clear, so let's try and use this formula with some questions now. What is the gravitational force between an 80 kilogram person and a 60 kilogram person 100 meters away? What is the gravitational force between an 80 kilogram person and an object of 2 times 10 to the 30 kilograms, which is 1.635 times 10 to the 8 kilometers away? What assumption have you made in each of these questions? Okay. So take a moment, use the formula to try and answer these questions. You should come up with 3.2 times 10 to the minus 11 newtons. So that means the attraction between two people, even if they're 100 meters away, is actually a very, very small number. That's because of the very small masses. If we think about the attraction of the same person and a much more massive object, although a long, long way away, we get a slightly smaller force of attraction, 0.399 newtons here. Now, the assumption we've made in each of these questions, that these are point masses and not extended masses. So we're assuming that the distance is between the point masses and not from perhaps the surface of a planet. It is actually to the center of the mass of a planet. So that's my gravitational fields and forces for you. I hope that was useful.